In the depths where sunlight never reaches, a slow-moving giant glides beneath the Arctic ice, older than the United States, older than the printing press, perhaps even old enough to have witnessed the birth of the Ottoman Empire. This is the Greenland shark, a living fossil whose flesh is laced with toxin and whose eyes are haunted by parasites. Scientists now believe some of these sharks have been alive for nearly 400 years, outlasting empires, plagues, and revolutions. What could possibly grant a predator such a seemingly immortal life? And how does a nearly blind hunter survive centuries in the dark? The real mystery starts here. Beneath the polar ice, where the water hovers just above freezing, a silent shape glides through darkness. The Greenland shark, Somniosus microcephalus, is a giant among Arctic predators, reaching lengths between 2.5 and 4.8 meters, sometimes more than 5 meters for the oldest known individuals. Its world is a realm of perpetual night, stretching across the North Atlantic and Arctic oceans, from the icy fjords of Greenland and Iceland to the deep waters off Canada and Norway. Most days, it drifts at depths between 200 and 600 meters, but some have been recorded as far down as 2,200 meters, where the sun's rays never penetrate and the temperature can fall to minus 1.8 degrees Celsius. Nothing about this shark moves quickly. Its pace is measured, almost glacial, rarely exceeding a single kilometer per hour. Tagging studies show individuals covering only a few kilometers in an entire day. In these waters, speed is a luxury few can afford. Life here favors patience and endurance over bursts of energy. The Greenland shark's flesh is dense and its body massive, built to conserve heat and energy in a world where every calorie counts. This is a habitat shaped by extremes: cold, pressure, and darkness. The shark's slow drift through this frozen realm is not a sign of weakness, but an adaptation honed over centuries. Here, survival is a matter of moving just enough to find food, just enough to avoid danger, but never more. In this undersea night, the Greenland shark is both ghost and sentinel, a presence that has haunted the Arctic depths for generations beyond counting. In the darkness beneath the ice, the Greenland shark glides with eyes clouded by invaders. Most adults carry a parasite called Omatocoita elongata, a pale thread-like copepod that burrows deep into the cornea. These parasites can reach nearly 4 centimeters in length, anchoring themselves with a plug that scars the eye and leaves behind milky patches of blindness. On some sharks, both eyes are marred, the surface pitted and opaque, vision reduced to little more than the faintest shimmer of light. Yet, even with this damage, the shark endures. It is not a rare affliction. Surveys of Greenland sharks across the North Atlantic and Arctic show that more than 80% are infected, some with multiple copepods per eye. The result is a population of near-sightless hunters, drifting through black water where sight would seem essential. But these sharks are not starving. Stomach contents have revealed a menu as varied as the ocean itself: halibut, cod, lumpsuckers, even the remains of seals and reindeer. Some have been found with entire polar bears in their bellies. How does a predator nearly blind, moving at a crawl, find enough food to survive for centuries? The answer does not lie in vision. Instead, the Greenland shark relies on senses tuned to the deep, the faintest trace of blood in the water, the subtle pulse of movement, the electric signature of life. In a world where light is a memory, the hunter's tools are invisible. But the question remains, how does it thrive when so much of its world is hidden from sight? A mouthful of Greenland shark is a dare few accept twice. Its flesh is soaked with urea and trimethylamine N-oxide, TMAO, a chemical shield built molecule by molecule over centuries. In the muscle, TMAO and urea reach concentrations hundreds of times higher than in most fish. To a predator or a hungry human, the result is not just a foul taste, but a swift lesson in Arctic chemistry. Eat it fresh, and the body reels, staggering, vomiting, a drunken confusion that can last for hours. Sled dogs fed raw shark meat have been seen collapsing in the snow, their legs splayed, eyes rolling, unable to stand. Hunters call it shark drunkenness. The symptoms pass, but the warning lingers. Yet the shark's toxicity is not just a quirk of evolution. TMAO and urea stabilize proteins, protecting cells from the crushing pressure and freezing cold of the deep. This chemistry is both armor and adaptation, a way to survive where few animals can. For centuries, Inuit hunters have known how to turn poison into resource. They never eat the meat fresh. Instead, they slice it into strips, boil it, and pour away the cloudy water, or hang it in the chill wind for weeks. Sometimes they bury it in gravel or snow, letting time and bacteria leach away the toxins. Only then does the flesh become safe food, mostly for sled dogs, sometimes for people. Across the ocean, Icelanders ferment the meat into hakarl, a delicacy for the bold, its pungency a reminder of the shark's chemical defenses. In the Arctic, survival often means learning the rules written by the oldest inhabitants. The Greenland shark's flesh is a boundary, a warning line between the living and the unprepared. Growth for the Greenland shark is a race measured in fractions of a centimeter. Each year, a typical individual adds only about half a centimeter to its length, sometimes a full centimeter, but rarely more. A 5-meter giant in these waters is not just old, it is ancient by any measure, the slow build of living tissue over centuries. Such glacial progress is no accident. In the near-freezing depths, every heartbeat, every cell division is slowed to a crawl. The shark's metabolism runs at the lowest setting possible for a vertebrate its size, conserving energy and limiting the chemical wear that ages most animals long before their time. This slow-motion biology extends deep into its cells. Recent enzyme studies have revealed something extraordinary. Key metabolic proteins in the Greenland shark show no measurable decline with age. Enzyme activity remains as robust in a 200-year-old shark as in one just starting its long journey. Where most animals see their biochemistry falter and their cells accumulate damage, this shark's machinery keeps humming decade after decade, as if time itself has little grip. The story continues in its DNA. The Greenland shark's genome is immense, over 6.4 billion base pairs, the largest of any shark yet sequenced. Within this genetic sprawl, scientists have found an arsenal of duplicated genes devoted to DNA repair and tumor suppression. There are extra copies of the molecular tools that fix broken strands, monitor cell division, and patrol for rogue mutations. This expanded toolkit may guard against the slow accumulation of errors that, in other creatures, lead to aging and disease. In the cold, dark sea, these sharks have built a fortress at the molecular level, where longevity is written into every cell. Yet for all this evidence, one question lingers: just how old can a Greenland shark truly be? Inside each Greenland shark's eye, a tiny core of lens protein holds a record of time. These proteins form before the shark is even born, and then remain unchanged for the rest of its life, untouched by the slow drift of decades or centuries. Scientists realized they could use these inert proteins as a time capsule, capturing the chemical signature of the ocean at the shark's birth. During the 1950s and the 1960s, nuclear tests released a spike of radioactive carbon called carbon-14 into the atmosphere, which quickly spread through the world's oceans. By measuring carbon-14 levels in the lens nucleus and comparing those levels to known patterns called the bomb pulse, researchers could anchor a shark's birth to a specific era. This method, precise and resistant to the uncertainties that plague other aging techniques, opened a window into lifespans once thought impossible. In 2016, a team led by Julius Nielsen analyzed the eye lenses of 28 Greenland sharks, using radiocarbon dating and Bayesian models to estimate their ages. The largest shark in the sample, a 5-meter female, stunned researchers. She was calculated to be about 392 years old, with a possible range stretching from the early 1500s to the dawn of the Industrial Age. This means she was already gliding through Arctic waters when Shakespeare wrote his first play, and when Galileo turned his telescope to the sky. The numbers forced scientists to redraw the timeline of vertebrate longevity. No other known animal with a backbone has come close. The Greenland shark is not alone in its slow journey through time. The ocean quahog, a clam named Ming, lived for 507 years beneath the North Atlantic. Bowhead whales glide under Arctic ice for more than 2 centuries. Yet among these ancient survivors, the Greenland shark stands as the longest-lived vertebrate ever measured. Right now, scientists estimate some Greenland sharks swimming beneath Arctic ice were born before Galileo looked at the stars. Their existence proves the deep sea still holds secrets older than nations and empires. In a world racing ahead, some mysteries endure, unchanged, waiting for us in the darkness. What else lies undiscovered?